All right, so this is a continuation of 7.1, finding the area in between curves, okay? This question that comes from slide 12 says find the area of the region bounded between f of x and g of x. Now, I know that x cubed is going to look something like this, and a negative x squared is going to look something like this. This is just by knowing my basic parent functions, okay? Now, because there are many curves happening here, I can't just go straight to putting it on. There's also transformations going on. So the first thing I'm going to do today is I'm going to find, instead of graphing first, I'm going to find the points of intersection. And the way that I do that is by setting them equal to each other. So we say f equals g when 3x cubed minus x squared minus 10x equals negative x squared plus 2x. Now, my suggestion to you is to move everything over to the same side. So I'm going to, let's get a different color. Add this x squared, which also happens to cancel out here. And I'm going to subtract this 2x, subtract the 2x. So now I have 3x cubed minus 12x equals 0. All right? What is the next thing that I can do? Beautiful. I can factor out a 3 and an x. And I'm left with x squared minus 4 equals 0. A reminder that when I'm separated by multiplication, I could set each of them equal to 0. So I can say 3x equals 0, and I can say x squared minus 4 equals 0. Divide the 3 on this left side, and what do I get that x equals? Nice, so here's one of my points. Here I'm going to move the 4 over. What does my x give me here? Nice, I heard some 2s, and I heard some plus or minus 2s. Be careful. A way you can quickly check yourself on that. What's my highest exponent here? 3. So how many answers should I have? 3. So if you saw yourself that you only put 2, that's your red flag to say, oh, I'm missing a number. Okay? So if I were to start to draw this, I have 3 intersection points. Okay? So 3 points where they intersect. Before I had 2 points where they intersect. And then within that area, I had some bounded region that I could check above and below. How many bounded regions do you think I'm going to have if I have 3 intersections? 2 bounded. I have a bounded area between the first 2, and then a bounded region between the second and the third. Does that make sense? So, if I'm creating a number line, right, let's say here's 0. This is going to be my y-axis. And then I have negative 2 and positive 2. So that means that I'm going to get one region here and another region here. Does that make sense? So what is an easy number to test in between negative 2 and 0? Negative 1. So I need to test f of negative 1 versus g of negative 1. Okay? So when I go set up my integration, I'm going to have to do 2 sets of integrations for this question. One for each of the bounded area, and then I add their quantities together. Okay, so here's the first one. Okay, take a moment to find what f of negative 1 gives you. Okay, guys, what did you guys get for f of negative 1? 6. Good. And then g of negative 1?
Negative 3.
Good. So on this left portion, who is on top? Okay. And who is on bottom? Right. So this is for my left portion. What for my right portion, what number do I want to pick that's easy between 0 and 2? 1. So go ahead and plug in f of 1 and g of 1. And I'm going to move this paper up for a moment, then I'll go back down. All right. So for f of 1, what did we get? Negative 8. And for g of 1? 1. So for this portion, who is on top? And who is on bottom? Okay. So without having to continue drawing this, I can already set up my integration. Okay. So I have my integral from negative 2 to 0. And within this portion, this first part, who do we say is on top? F of x, which, let me scroll back down, is right here. Minus the bottom, which would be g of x. Okay. And then plus, I'm going to have to write underneath. I'm running out of room, okay? Plus the integral now from 0 to 2 of who's on the top on this portion? Nice. G of x. So now I'm going to write g first. Minus the bottom, which was f of x. Sorry, I ran out of room there, guys. Do you understand what I wrote? Okay. Okay, so without drawing, I was able to find out my setup, which then my next two steps would be to clean the inside of the integral, make that way simpler, and then do the antiderivative, f of b minus f of a, all the way till there. Okay, but for those of you who want a better visual, I'm going to take a moment and give you some additional information. Okay, based on my skills that I know from previous courses, g of x, let's look at this one first. I know g of x. If I want to know where this hits the x-axis to get some more details, I set that equal to 0. Okay? Factor out a negative x, and I can say x equals 0 and x minus 2 equals 0. And I can see where this hits the x-axis. So not only do I know where they're going to crash into each other, I also know where this hits. Okay? So I know that I have one parabola facing down that hits at 0 and at 2. Okay? So it's going to go something like this. Okay? And now if I want to do the same thing for f, I mean, I already know who's on the top and who's on the bottom. Okay? I can say 3x cubed minus x squared minus 10x equals 0. Highest exponent is 3. I should hit 3 times here. So I can factor out an x. I could say this x equals 0. And now I can factor this out into 2 binomials. 2 numbers that multiply to give me 10, but combine with this 3 to give me a negative 1. I have a positive 5 and a negative 2. Okay, so I know I did that factoring a little quick, but it's just, again, to show you the image. All right, so now that we know that point of intersection, again, we know this is a cubed. So we know it's going to hit positive 2. Okay. It's going to come back and hit 0. And then I need this portion. And it'll come back up and then hit, let's say this is negative 1 point something. And then we also know that at -2, they're going to intersect. So somewhere around here, they're going to intersect. So there is your visual of my first section that we just wrote, okay, with F being on top and G being on bottom. And then our second section with G being on top and F being on the bottom. So if you wanted more of a visual, we have from -2 to 0, F minus G. Here's our F minus G, our top minus bottom. And then from 0 to 2, we have G minus F. Okay? So again, this drawing and this math up here is not necessary. This is just an additional help in case you want more of a visual. But with testing a number in between, you can figure out your setup. Okay? So now I need to clean. I need to distribute this negative. Make sure you distribute them to both terms. And here to all three. Biggest mistake on the AP is that everyone does all of this math correct, but they forget to distribute the negative all the way through. And then they mess up the term, which messes up their final answer, okay? So I have my first one from -2 to 0. All right, all I did was distribute my negative here. My next step, I'm going to combine like terms, okay? So this works out kind of nice where these two terms cancel. And the same should happen over here. And then these two will combine. We see that, guys? So I have all right, and this portion shouldn't be too bad because my antiderivatives do end up being the same. Antiderivative here. Good, and then here. Good, and this goes from -2 to 0. Plus, same thing, just opposite signs. Beautiful. And then now from 0 to 2. Okay? So we have my function at B. What is my function at B going to be? When I plug in 0 into both of these, I'm just going to get 0. So f of B minus, now here I got to plug in okay? So this is my first portion, plus, I'm plugging in my +2, my f of B, minus, what is my function at A going to be? And you are done. This is your final answer. Whether you write these zeros or not does not matter. Now, if you do not write this 0, the reason why I like to go in and write these zeros is to make sure you don't mess up and forget this negative. Because your function at B is 0, but you still have minus f of A. So be very careful not to miss that negative, okay? So before we look at this next question on slide 13, it's up here. I'm going to refer you back to the notes we took last video, okay? So down here we started talking about right minus left, okay? So notice that these equations are x equals and they have y values, okay? So when we have x equals y values and the functions come out in the drawing, sorry guys for the bell, and the function comes out sideways where you can clearly see a right and a left, that's when we're going to use this second version, okay? So when we set them equal to each other to find our points of intersection, or A and B, A and B are going to be y values now, and my functions are going to have x equals y values, okay? So let's come back over here, and let's analyze the functions for a second. Back in previous courses, we talked about when we had a negative y squared, that was a parabola facing to the left, okay? Now, if I were to move this 3 over, it would say x minus 3, okay? Whenever I have a transformation with the x, it moves side to side, opposite the sign, so that means this parabola would go 3 to the right, okay? And now here, this, because it's y to the first power, is going to be linear. If I did change this around to move the 1 over, I'd have y equals x minus 1. This would just be a linear function that went 1 down. Okay? So, if I start my sketch, I can say 1, 2, 3 to the right is some parabola like this. And then this linear function goes 1 down. I don't really know where this 1 lands with respect to the parabola yet, but it's going to be diagonal. Okay, so before I draw it, let me find out where they intersect. I'm going to set them equal to each other. So I'm going to say 3 minus y squared equals y plus 1. Move everything to one side. Because this y squared is negative, I personally like moving it to the side that makes it positive. So I'm going to move this to the right. So I'm going to say positive y squared plus y, and then subtract this 3 over. 1 minus 3, whoops, is negative 2. Okay? This gets factored into two binomials. Two numbers that multiply to give me negative 2, but combine to give me positive 1. Good, because my middle term needs to be positive, my bigger number needs to be positive. So they're going to intersect when y is positive 1 and when it is negative 2. Again, you are not talking with respect to x. You are talking with respect to y's. Okay? So, let's say they crash here. I know this is going to hit at 1. Okay? And then over here, somewhere wherever 1 is, it's also going to hit. Okay? So we can see a negative 2 is where this one hits. And then up here, a positive 1 is where this one hits. Okay? So for this shape, I am working with right minus left. Visually, this should be very easy to see who my right is and who my left is. Okay? But if you feel like that's still a little much for the drawing, what is an easy y value in between these two? 0. So I'm going to say my first x function at 0 would give me 3 minus 0 squared, which just gives me 3. And then my second function at 0 gives me 0 plus 1, which is just 1. So you can see again that the y squared is my top. Or not my top, sorry, my right. Okay. We could also see here, this is my right. And here's my left. This is the one I decided to be my right, and this one here is my left. Okay? So now should be the easy part. I have my integral from, who is my a? Good, -2, my smaller number, up to 1. And now my right function, which is 3 minus y squared, minus my left function. And because this is with respect to y, I put dy. The next steps go the same, okay? I am going to distribute this negative, okay? Clean up that middle. Okay? And once you've cleaned, you are ready to do your definite integral. So antiderivative first. Make sure you're not writing x's here. Make sure you're writing everything in terms of y. And then lastly, I have f of b minus f of a. When you guys take this quiz and test with me, you will be allowed to leave it just like this, okay? And that is your final answer.